Hello everyone, my name is Thomas van Gemert, and today I'd like to talk to you about how doorways do not always cause forgetting. Not always, but that implies that sometimes they do. How is that possible, you ask? Well, I'm talking about a phenomenon from psychology, colloquially referred to as the doorway effect. The doorway effect is that you are more likely to forget things after crossing an environmental boundary compared to staying within the same environment. This environmental boundary can be many things, but the effect has been typically studied by using a doorway. In the comic you see here on screen, this effect is illustrated as follows. A virtual reality user is on her way to the library to get a book. To get to the library, they have to step through a portal to the next space. When the portal here acts as an environmental boundary, so that when they arrive in the library, they have forgotten what book they were looking for. The doorway effect, or the location updating effect, as it's also known, is predicted by event-based theories of memory. In particular, the event horizon model of memory, as explained by Radwanski and Sachs in their 2014 book and their 2017 paper. The idea is that when you move to a new space, a new event is created, and items are stored in relation to specific events. So when going to a new space, the previous event is stored in long-term memory, and a relevant item, for the book in the comic, for example, can then be present in both the old and the new event. When you're trying to remember the relevant item that you want right now in the new event, the double presence in both the events causes interference and can prevent you from correctly remembering. In other words, it can cause forgetting. The doorway effect has been studied in several studies. One of the first studies that studied the effect in virtual environments on desktop computers was Walking Through Doorways Causes Forgetting by Radwanski and Copeland in 2006. And Radwanski and his colleagues have demonstrated the existence of this effect in several different study settings, both in real life and with virtual environments. For example, they used smaller and bigger screens, they used see-through walls separating the spaces, different travel distances, different time to allow you to forget, and a whole host of other papers. So, in general, the effect seems to be pretty robust. However, in immersive virtual reality, where the user typically wears a headset and uses body-based interaction, the existence of the effect is still unclear. In 2021, McFadden and colleagues found no effect in virtual reality whatsoever, and no effect in real life. On the other hand, Van Helvoort and colleagues in 2020 did find an effect similar to a doorway effect in a virtual reality museum. Apart from this unclarity, there's two ways virtual reality design can affect the doorway effect. In particular, we can design virtual reality locomotion techniques in non-realistic or new ways that affect how we cross these spatial boundaries that segment the events. We can also design virtual reality environments and how the user interacts with these environments in new and non-realistic ways. For example, it doesn't have to be a door, it can be a portal, or it could even be the transition from one visualization to the other when you're teleporting between two areas. So this paper aims to answer the following three questions. Does the doorway effect occur in immersive virtual reality? How does the doorway effect depend on locomotion technique? And how does the doorway effect depend on the boundary visualization? And to answer these questions, we set up two controlled user studies. In the first experiment, we had one group of participants come in and use normal walking as a locomotion technique, and the other group uses teleportation as a locomotion technique. In the second condition, we either had participants walk through a door or not, and we alternated this throughout the experiment. The first experiment conceptually replicates previous work in its study design and environment design, and it was pre-registered, and we invited 40 participants, 20 per group, to participate. The environment looks like this in a top-down view. This is a room with various furniture, of which the positions and visualization is randomized. And in this case, there's a wall dividing the room into two smaller rooms in the middle, and the wall has a door in it. So in this case, this is the door condition, where the user walks through a door to get to the target table on the right. They start at the table on the left, where there are 6 objects of simple shapes and colors, and the participant has to grab these objects and put them in the box and remember the objects. When they have all objects, the box closes and they walk to the other table, either walking through a door or not. When they cross through the door, we present them with an object recognition probe that asks, for example, is there a red cube in the box? Yes or no. We do this 6 times. In the no door condition, the middle wall and the door are not there, and it's simply one big room where the participant walks to the target table. The idea here is that we measure the error rate on these object recognition probes, and we hypothesize that if the error rate is higher in conditions where participants walk through a door compared to when they did not walk through a door, that demonstrates the doorway effect because they are more likely to forget. We used 40 trials in total with 6 of these memory probes per trial, and we modeled the data, we modeled the effect of condition on error probability using Bayesian models, and to further support our data analysis, we also applied an ANOVA analysis on all the conditions. In the second experiment, we basically repeated the first experiment, but we only used walking as a locomotion technique, and instead we varied the visualization of the doorway. We used 20 participants again in this group. The doorways were visualized as follows. We had an ordinary door on the top left, that was the same as in the first experiment. We had a transparent sliding door, we had an opaque sliding door, and we had a portal to represent a non-realistic visualization as well. And of course, there was a no-door condition. The results are somewhat surprising. We found absolutely no difference between the door and no-door conditions, either for walking or teleportation in the first experiment. In the graph here, you can see the estimated probability of making an error. This comes from the Bayesian models. And in blue, there's a difference between walking conditions, no door and door. And in red, there's for the teleportation, door and no door. You can see quite obviously that there is no difference and the credible value intervals overlap completely. The ANOVA as well did not find any significant effects. There is a small difference between teleportation and walking, but this is almost completely explained by differences in travel time, so we cannot conclude that teleportation causes more forgetting. In the second experiment, we also found no significant differences between doorway visualizations. Again, this is the estimated probability of making an error, and for all the conditions you can see that the credible value intervals overlap almost completely, and the ANOVA analysis found no significant differences. So what does this mean? Well, on the one hand, this is kind of surprising because the previous work suggested that the effect is quite robust, and yet we did not find any doorway effect, and at least one other virtual reality paper that investigated the doorway effect also did not find a doorway effect. We discussed several potential explanations in the paper, but there's no clear reason of why we could not find a doorway effect compared to the other related work. At this point, we believe that if the doorway effect would be practically relevant, we would have observed it. We would have observed anything, a trend even. This also means that the effect is clearly not as robust as the previous literature suggested, and the theory that predicts a doorway effect should do a better job of explaining when the effect does and does not occur, and for what types of objects in memory it should occur, and for which one it should not. Second, this means that in terms of designing virtual reality environments and virtual reality locomotion techniques, we predicted a scenario where forgetting could be worse in virtual reality than in real life because of the doorway effect. However, this does not seem to be the case. And finally, this paper is a good example of how a relatively unknown effect could potentially affect virtual reality experiences. And in this case, it probably does not, but it is important to keep considering how cognition and memory in virtual reality environments, which can be very non-realistic, can be affected. I'm happy to discuss this paper further, either in person at the conference or over email. You can reach me at the following email address, and I hope to talk to you soon. Thank you.